Good day everyone. In today's video, I'm going to be talking about the evolution of ChatGPT and will try to decipher the magic behind its working in relatively simple terms. In case I use some terms that you are not familiar with and would like to have a deeper understanding of, do let me know and I will make a more detailed video on those topics. Before we delve into ChatGPT, let's take a look at its evolution. In 2017, Google came up with the paper Attention is All You Need. This paper formed the foundation for the transformer architecture, which is a neural network architecture upon which many LLMs or large language models are based on. In 2018, GPT was introduced, which is based on a modern transformer architecture and it's a generative pre-trained transformer that is trained on a large corpus of words. In its first version, GPT was trained on a book corpus database of around 7,000 unpublished books using unsupervised machine learning, which is akin to having the model learn the relationships between the words and different contexts without actually having to teach it. On top of that, supervised fine tuning was applied on specified tasks where humans provided the desired input and output and the expected results so that the model could correct itself better. In 2019, GPT-2 was released, which was trained on an even larger corpus of around 150 billion parameters. With the increase in parameters, it was observed that the model performed even better using unsupervised machine learning techniques even without supervised fine tuning. Eventually, in 2020, the release of GPT happened, which was now trained on 175 billion parameters, and it was observed that the model learned to perform language tasks much better once prompted with a few examples in the prompt text. The user gave the prompts and also a few examples in the text, and the model was able to understand the context and respond in a much better manner. This led to the exploration of how the model would behave and learn with constant human feedback. This then led to the development of InstructGPT, where the model learns from human feedback and uses what we term as RLHF, that is reinforcement learning from human feedback, to improve with each iteration. This finally led to the creation of ChatGPT, which gave the conversational dimension to the user, where the user could conversate with the machine and it would constantly learn from the human feedback and correct its response accordingly using RLHF. Now you must be wondering, what is the magical transformer architecture we talked about? The simplest way to think of it is by breaking it down into four high-level components: embedding and positional encoding, encoder, decoder, and linear and softmax layers. Let's take a look at each. Embeddings. Embeddings and positional encoding is responsible for turning words into vectors of numbers. Since neural nets can only process numbers, so the words are converted into a vector of numbers and we have many vectors for each word. Encoder then processes each input sequence and tries to find the similarity between the different vectors. Think of this as paying attention to each word and trying to analyze how it is related to the previous words in the corpus, thereby generating context. When we read a book, we try to understand each word and how it is related to the other words. Decoder then generates a probability distribution of vectors of numbers based on input sequence with some amount of randomness as preferred by researchers to prevent the same results every time. And lastly, we have the linear and softmax layers which transform the decoder output to words. Now, since we have grasped the evolution of the transformer architecture and the evolution of ChatGPT, let's take a look how ChatGPT actually works. Let's take a look at the training mechanism used for ChatGPT and its sibling, that is InstructGPT, from which it has evolved. So for ChatGPT, we have a prompt samples taken from the dataset, and the human labelers provide the expected output for each prompt sample of the dataset. That sample is then fed into the GPT-3 model, and we get the supervised fine-tuned model. That is, the model learns for each prompt sample what is the expected output, and it is able to contextualize its response better to fit with the human expectations. Now, the prompts are then fed into the SFT model, and the outputs of the SFT model are captured, and the humans then use a ranking mechanism to rank how good the outputs were to the expected output. And this is fed into the reward model to create a reward model. Now, this reward model is used to provide feedback to the SFT model on its outputs. So, this is how it learns from the once it provides an output, it learns how good was the output as expected to the results which were desired by humans. And in ChatGPT, we have added the conversational elements where humans constantly provide feedback and interact with the chat GPT as if it's talking to a normal human being, and the feedback provided by the humans as a part of the conversation element is used by the model to retrain itself. But the model provides a probability distribution of the output sequence of words. So how does it do that? So basically what the model does, it provides the best next token for the input sequence of words, and it applies auto regression to then generate the next sequence of words using the previous sequences. So this is how it is able to successfully generate the output. And by using RLHF, it is able to improve its response every time by constantly taking feedback from the user who is operating the chat. So this is a short, brief explanation of ChatGPT and how it works and the magic behind it. If there are certain elements that you would like me to create more videos on, like about transformers or how the detailed encoder decoder components of a transformer architecture works, do let me know, and I'll try to create some videos of the same along with some examples. That's about it for now. If you like my video, please do subscribe to my channel and like and comment on my video. Thank you.